Hey everyone, we're group 34. We're doing problem 11 of chapter 11, 23rd problem. And if you look at here, we have a frame which has 4 connections, A, B, C, and D. Connection A is a fixed end, D is a pin, we have B and C which are rigid. And we assume that the length of the structure does not change. So we have AB and DC which is equal to 18. And we have BC which is equal to 15. So, and we have a force acting as is shown here at the maximum being 60 kip per feet. So, we're trying to solve for the moments at all the locations here on the frame. So first step in solving it is to draw an approximate diagram how this would be bending under the load conditions. So we see here that there's a slight bend here, and how the frame would bend and the deflections would be. So here it shows the sign convention that we have taken for the moments as well as the shears. So once we understand this, we'll come back to the sign conventions again. So here we have degree of freedom. At A, which is a fixed end, we know that there is not going to be any deflection or rotation, which makes delta A equals to 0 and theta A equals to 0. Now when we go to B, we have a delta as well as a theta. That means we have a rotation as well as a deflection. At C is the same condition. We have a rotation as well as a deflection. When it comes to D, it's a pin, so there is not going to be any deflection, but we're going to have a rotation. Since, as in the beginning we have told, we have assumed that the length of the structure does not change. So it is safe to assume that delta at B is equal to delta at C. This is what we have shown in the degree of freedoms. So again, going through each point, delta A equals to 0, theta A equals to 0, we have an unknown theta B, we have an unknown theta C, we have unknown delta B and delta C, but they're equal to each other. Now at point D, we have delta D equals to 0 and theta D, which is unknown. So we have totally 1, 2, 3, 4, 5 unknowns here. So we need basically 5 equations to solve for the 5 unknowns to come up with all the shears and moments, right? So we have our first equation right in front of us, which is delta B equals to delta C. So we need 4 more equations to solve for the other 4 unknowns. So we would be using the equilibrium equations that we have here to solve for this. So let's see how we came up with this. If you see here the moment diagram, at B, we have one moment going in positive direction, one in the negative. That is, one is in the clockwise, one is in the counterclockwise direction, which makes moment at BA is equal to moment at BC. Similarly, we have at C, one going in the clockwise, both of them going in the clockwise direction. So that would make moment at CB equals to moment at negative CD. So, and then we have moment at D equals to 0 over here. And then we came up with an equation, shear at BA plus shear at CD is equal to 0. How did we come up with that? There's a shear at A and D, which both would be acting towards the left. And see, we cut the beam over here the same way we do at the bottom. And then this assuming that there is no force acting at this point, so the shears would be equal to 0 when we sum them up. That's how we come up with the equation VBA equals plus VCD equals to 0. Now in the next step, we'll go ahead put the matrix equation, solve using the matrix equation for each moment, and then use substitution methods to solve for each of the moments.